In this video, we're going to look at how to create an Excel machine, right, that will always compute the t-stat and p-values when we're running a hypothesis test for two means when we are given the statistics, given the stats of each group, each sample. And of course, the population standard deviations are unknown and assumed to be unequal with these types of tests. Because if they were known, we'd be doing a z instead of a t. Okay, first things first, let me clear out this template, right, that's linked in the description. Okay, now we can concentrate on just this one formula. Again, in this example, we're given the statistics. We're given the sample size, the mean, and the standard deviation for both of our groups, right? Group 1 and Group 2. Okay, the first thing we have to do is calculate the degrees of freedom, which is a terrible formula. There are other simpler ones that give you kind of rough approximations, but if you want to get the true degrees of freedom, and usually you have to have the precise one to get the correct answers, you have to use this monster. Now, just the syntax alone can be confusing. Just know that this S sub 1 with this little 2, this just means S sub 1 squared. This just means the standard deviation from sample 1 squared, right? So there's our standard deviation from sample 1. We just need to square that. And same thing here, right? That one squared, and then the one from the second set squared. So those are those weird things. That's what that means. And then you can see the rest of it. I mean, it's not tough math. It's just tough to do it all in one fell swoop. Like if you wanted to try and type this whole thing into this one cell, it ain't easy. It ends up being this horrible expression. And you can see that that's very complicated, which if you want to just pause the video and copy that down and put that, into your cell, that's fine. Because we want to learn some Excel skills here, but this is a little out there. But in any case, I think if you wanted to actually build this yourself, what I would suggest would be over here. So I'm just going to put this in so it's there. Is like this, I would say, equals my standard deviation squared, right? And same thing here. Equals my standard deviation squared. Now you're thinking that those numbers are wrong, and that's just because it's not showing enough decimals. So now when I wanted to create this by hand, I could call out these two cells for these things here, 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 and here, which would make my life a lot easier. I mean, you could even do this, right? Create that number as equals this minus 1, and same thing here, right? Equals this sample size minus 1, and then you'd probably want to label them, right? And minus 1, and like s squared, et cetera, et cetera, et cetera. Okay, once we get beyond the degrees of freedom, then we can tackle our t-stat, which is a lot easier formula to create. We've done these types of computations before, and they go relatively smoothly. Again, this is the generic formula that shows in case the difference in the hypothesized population means is actually something other than 0, then this is how you put it into the formula. Like previous videos, I've said 99.9% of the questions out there, the null hypothesis is going to be that the two population means are equal. They're the same. So when you take one of them and subtract the other one from them, this just becomes 0. And then when you subtract 0, it does nothing. And basically the top of the fraction just becomes the difference in your two means. But we could very easily, put in a cell down here and call it, population mean difference. And then this would be the value, like for instance, they said, oh, we think this mean is going to be 10 points bigger than that mean. So our difference is going to be 10 because it's going to be 10 minus 0. Or, if this one's bigger, then it'd be negative 10, that kind of thing. And then we can build that into our formula. So I'm going to put this to 0 because that's what it almost always is. Or if you just leave it blank, it's going to be the same thing. But in any case, we're going to do equals. We need parentheses. And if we're going to use the number at the bottom for the mean difference, we're actually going to need 2 of them. Because inside the second set of parentheses is where we're going to do just the difference of our means. So it's going to be the mean of our first one minus the mean of our second one, close that parentheses, and you can see those red parentheses are basically modeling these. Then we subtract the population difference. That number just represents this whole thing. And then we finally close off the outside black one to make this all one big thing that can now be divided by the bottom. And the bottom, of course, is square root of some stuff. Well, what's it going to be? It's going to be this thing squared divided by n1. So you could just use this, right, and square it, or you could go ahead and use this one. This thing squared divided by n1 plus the other one, that one squared, divided by n2. And then close parentheses, because that's the end of your square root stuff. Hit enter, and there is your t-stat. Now, p-values, very simple. Just like before, I said the easiest thing to do is to always treat your test statistic as if you got the positive test statistic, right? So the positive version of this. And then we know that we're always going to do 1 minus the XL function because we want the upper tail in that case. So this is going to equal, and instead of norm dot distribution, we're now on the t-test. So we're going to do t dot distribution. And you'll notice that it does give you the option for two tails and right tails and all that fun stuff. So we could just do the right tail test here rather than doing 1 minus. So either way, you could do 1 minus t and use the normal t distribution, or you could just do the right tail t. Some of you might have an older version that doesn't have these two options, so you'd have to do 1 minus t distribution. We're going to do the right tail test. So now that just means we always need to use the absolute value, right? The positive value of our t-stat. So we're going to do ABS for absolute value. We're going to click on this cell. So now we have the absolute value of our H31 cell, right? That's the X we're dealing with. And then comma, all it needs now is degrees of freedom, that ugly formula that we did there. Close it off. There is our p-value. And then, of course, the two-tail is always simply just equals the one-tailed times 2. And we now have a calculator that will do 2 means when we are given the statistics of each of our samples. And of course, the population standard deviations are not known, and that's why we're doing a t-stat instead of a z. And we are not assuming equal variances between the two samples, which is very rare to do. So we basically have unequal variance. In fact, if you assume equal variances, the formula for the degrees of freedom changes, and you got to do another ugly one. Okay, thanks for watching.